Hello and welcome to this video brought to you by Smart EduHub Mumbai, world's largest providers of topic-wise past papers and now also the largest providers of IGCSE study material. The topic stoichiometry has been taken from the study material that has been made by Smart EduHub for IGCSE. Every attempt has been made to break the available topic into as many subtopics as possible. This helps children to master the smallest of concepts that are possible. Another important thing to note is we have taken examples which are from original IGCSE past papers and have presented the complete solved solutions in the video. This helps you to understand how to answer a particular type of question, and a different variety of questions have been taken under every subtopic. So you will even get an idea about the different type of questions that can be asked for a particular subtopic. A very important thing to note is all information in the notes agrees with the IGCSE requirements and the mark schemes. This means that the material that you will find in this video is 100% reliable, as in the other videos. The first subtopic is mole, and as you can see, there are 5 different definitions of a mole. You can choose the one you like the most. The second subtopic is Avogadro constant, and here again you can see there are 4 different types of definitions that have been given to you. You can choose the one you like the most. The third subtopic is relative molecular mass (mR) or the relative formula mass, again mR. As you can see, these are very relative terms and therefore they do not have any units. Definition has been given to you. Also, it has been mentioned that one must know to calculate the MR, as it is required in 90% of the sums one comes across in stoichiometry. Let me tell you, 90% is just a number I thought of. It could be even 99 or 100%. What I mean to tell you is, it is a very important concept without which you cannot begin doing higher order sums in stoichiometry. So the first example I have taken is, another fullerene has a relative molecular mass of 840. How many carbon atoms are there in one molecule of this fullerene? Mass of one carbon is 12 grams. Hence the mass of X carbon atoms is 840. Simple cross multiplication gives you X is equal to 70. Thus there are 70 carbon atoms in one molecule of fullerene. The second question is a direct calculation of the relative formula mass of CaCO3 and CaO. MR of CaCO3 equals AR of Ca plus AR of C plus 3 times AR of O. That gives you a total of 100. Again, no units have been written. The fourth subtopic is calculating the mass or the number of moles and the MR using the formula mass equals number of moles into MR. Example has been taken from October-November 2006, paper 3, question 3b2. As you can see, this is a question about the decomposition of calcium carbonate into calcium oxide and carbon dioxide. 7 kilograms of calcium oxide was formed. What mass of calcium carbonate was heated? The first thing is to write down the ideal mole ratio, which is 1:1:1. Then note down whatever information has been provided. As you can see, 7 kilograms of calcium oxide was formed. So therefore we have the mass of calcium oxide. MR of calcium oxide we can calculate by looking at the values from the periodic table, and that gives you a total of 56. So the number of moles of calcium oxide is equal to mass of calcium oxide divided by MR of calcium oxide, which is equal to 7 divided by 56, and that gives you 0.125. Now, again going back to the ideal mole ratio, CaCO3 is to CaO is to CO is 1 is to 1 is to 1. So therefore it means that the moles of CaCO3 and CaO and CO2 are equal, and they are also equal to 0.125. Now, once you know the moles of CaCO3, it's very easy to find the mass of CaCO3. We can simply find it by multiplying the moles of CaCO3 by the MR of CaCO3, and that gives you 0.125 into 100, which is equal to 12.5 kilograms. The fifth subtopic is calculating the concentration, number of moles and volume using the formula concentration equals number of moles divided by volume. Unit is mole per cubic decimeters. The question has been taken from October-November 2010, paper 3-1, question 8b. It's better you pause the video, read the question and try solving the questions on your own, and then see if you're going wrong, where you're making mistakes. Do not try to look at this video as though you're watching a movie. It's very important for you to start solving the sum, pause it in between, match your answers with mine, and reflect where you've gone wrong. As you can see, first thing I've done is I've written the ideal mole ratio, which you can see is 1 is to 2 is to 1 is to 1 is to 1. Then, looking at the information, I understand that the concentration of HCl is given to me, the volume of HCl is given to me, and the volume of HCl is in cubic centimeters. The first thing I need to do is divide it by 1000 to convert it into cubic decimeters, because the concentration, as you can see, is given in moles per cubic decimeters. So, by multiplying the concentration by the volume, I can get the moles of HCl, which is my first answer. Again, the second thing is number of moles of COCl2 formed. Now, that I can get again by looking at the original mole ratio. So, moles of COCl2 are half the moles of HCl from the ideal equation, and therefore I have written it as 0.5 into 0.080, which is 0.040. So as you can see in blue, I have written the moles for each and every reactant and product that is present in the first equation, to give you an idea how to write the moles. The last thing asked to you is number of moles of COCl2 .6H2O form, that is the hydrated cobalt chloride salt moles they have asked you. Now as you can see, the mole ratio in the second equation is 1 is to 6 is to 1. This tells us that the moles of hydrated cobalt chloride formed are equal to 0.040. That's all in this video. Do watch other videos that cover the subtopics from 6 to 10 of stoichiometry. Also, do not forget to subscribe to get regular updates on all topic-wise past paper videos. Thank you for watching and have a nice day.